Absolutely. All right, well, good morning, everybody. How we doing?
Good morning.
So I'm going to do my absolute best not to bore you to death today and actually try to keep you awake. You probably haven't had your coffee or had a couple of cups, so try to slow down for you. Let me introduce myself. My name is Kevin Myers. I'm the network architect and a managing partner of ArchiTechs. You've probably seen us over in the booth over there, flying helicopters around and presenting some of the data center designs that we've got. What's the next slide here? So a little bit of background on me. Spent about 16 years in IT and network engineering, various things. I kind of started out as a server guy and then went towards the network engineering piece early in the 2000s. And during the course of that time, I've worked in service provider, enterprise, e-commerce, and government environments doing a lot of different things. Service provider is probably my favorite and where I've spent a lot of my focus, but recently we've started to focus on data center applications and designs. What IP Architects works with a lot, and what I work with a lot, are MikroTik integration with multi-vendor networks. So Cisco, Juniper, Adtran, all those guys, the things that we do, we're trying to make MikroTik fit into those larger networks where you've got a large MPLS core or a large data center, things like that. And BGP, MPLS, and OSPF are kind of our playground. That's where we live. It's one of our favorite things to do. If you want to get me really excited, get me talking about BGP and MPLS and OSPF. And large enterprise data center networks. Recently, I was fortunate enough to do the MTC-INE with Andis, which was very good. If you had a chance to do that, I highly recommend doing the INE with him. He did a fantastic job and is a very, very knowledgeable guy. So a little bit about IP Architects before we begin. Obviously, we gave away 2 RC helicopters. We got 2 more today. So if you like us on Facebook and then leave a message where we actually have your contact information, we'll enter you in the 2 drawings we have today to win one of the RC helicopters. And they're pretty decent size. They're like 17 inches. And we, last year, were the very first company to launch 24/7, 365 MikroTik TAC support. So everybody always wonders why we're giving away Tic Tacs, and those of you that were here last year saw our enormous Tic Tac container that we brought, which unfortunately UPS destroyed shipping it back. It was about as tall as this screen here. And that was too bad. But it's the MikroTik Technical Assistance Center. So we've got 3 tiers of engineering support. We've got level 1 support is up in Montana. Level 2 support operations is out of Dallas, and then Tier 3 architecture is out of Jackson, Mississippi, which is where Scott Hammersley and I are. And the MikroTik community has responded pretty well to that. A lot of people want the Cisco TAC type experience. They want to be able to have support that's 365, 24/7, and call and get an engineer to work on their problem, and have multiple engineers that can work together to solve a problem. So that's gone very well. One of the other things we do, we're also a carrier. We've got data centers out of Denver. We're also looking to add data centers in Charlotte. And we have a product called Mpls that partners with LTE. And basically, it's a portable last mile. You can basically deploy just about anything you want on it. We have peering with Verizon and have private transit through their LTE network. So rather than you go to Best Buy and you get an LTE type box and you get a public IP address, with our network, you actually get private transit through Verizon's network on LTE. So if you want to privately connect 2 sites, you can actually drop public if you want to do a BGP peering. We have a lot of people that like to do BGP peering backups in places where they don't want to pay for the bandwidth, but they drop it out. And if you guys want to stop by the booth, we can talk more about that. We also do proactive monitoring, ticketing, change control, IP address management, hosted software. And we do a lot of network engineering, design, and consulting for a lot of big companies. A lot of the companies we work with are large, publicly traded companies, Fortune 500 companies. And they've responded really well to integrating MikroTik into some of the larger environments. So let's talk about the MikroTik-enabled data center. What would the role of the MikroTik be within the data center? This is kind of a question we asked ourselves after we started working in some of the bigger data centers. We were fortunate enough to work on some really big data center deployments in like 50,000 square foot data centers, 100,000 square foot data centers doing Cisco Nexus, Nexus 7010s, Nexus 5Ks, FEXs, those kinds of things, which is kind of the bread and butter of the data center world. And as we were going through the designs and deploying these and looking at these things, we thought, we need MikroTik as well, and how can we leverage MikroTik in the data center and use MikroTik to do some things in the data center. And this is kind of what we came up with. So in the layer 3 core, the new CCRs that have the 10 gig interfaces, the 1036 8G2S pluses, are perfect for aggregating a lot of traffic within the data center. So you can bond those together into a 20 gig channel, which we're going to get into a little bit later in the presentation, and push a lot of traffic through. And I know some of you have stopped by our booth and we kind of had a preview of the data center design. A lot of you guys have looked at it to see what we're doing, and we'll get into that. You can do a top of rack end row solution, which is basically within the data center. You've got hundreds and hundreds of racks or dozens of racks, and you'll have like one rack that's kind of your core. And the top of rack end of row is just routers that connect to the core and route into the core. Typically, those tend to be very expensive when you're dealing in the Cisco or the Juniper or the Brocade world. And with MikroTik, with the throughput you can put through a CCR now, you can put those in pretty inexpensively. Using it to build firewalls. Firewalls not really going to be the focus of the discussion today. It's probably going to be a whole separate topic. But getting into load balancers, which if any of you went to Scott Hammersley's presentation, he touched on. We've been doing a lot with MikroTik and load balancers. We recently had a customer out in California that's right down the street from Cisco. They needed to scale OpenVPN, and they wanted to do 250,000 OpenVPN sessions. And we were like, well, okay, we'll give it a shot. And by using load balancers and some other technologies, we actually delivered 250,000 OpenVPN sessions on MikroTik to that customer. So we said, well, with the load balancers, what else can we do? And we found out firewall, because one of the big problems is not being able to exchange state between two CCRs. If you want to have active failure, the best you can do is use like Vrp and have an active passive. With a load balancer, the load balancer remembers exactly where it delivered traffic to. So by putting load balancers in front of a firewall, you can take CCRs and aggregate and build yourself as big of a firewall as you want to put CCRs in a rack. You could do, we're looking at testing 40 gig in our data center right now, firewall throughput, but you could go as high as you wanted to, as much as you have rack space. VPN aggregation is great. You can put a pair of them out there to VPN aggregate. A lot of data centers have tons and tons of VPNs coming in. They'll have hundreds coming in from overseas to get vendors in there and remote management and access. And you can pop up a pair of MikroTik CCRs, put them in a redundant state. You can actually put them behind the load balancer and do SSTP or IPsec or really whatever you want to. And then obviously Mpls, which is kind of the bread and butter of MikroTik, to segregate traffic within the data centers. And that's become a real popular thing in data center design, is using Mpls to say, I've got all these customers in my data center, I'm hosting this stuff for them, but I don't want them to be able to see each other. I don't want them to be able to talk together. So Mpls is a good fit for that. And then between the data centers, you can actually do Vlan extensions using MPLS L2 VPNs and the UIP together. You can do MPLS L3 VPN, which is the piece that separates routing tables and segregated traffic for customers between data centers. Vlan Rewrites, if you're merging two data centers together and you've got a VLAN on one hand and the same VLAN on the other, but they're two different things, you can do rewrites, and we're going to get into that. And then you can actually have multiple gateways from the same subnet at more than one data center. So that's something we'll get into in the end of the presentation. And if you're migrating like virtual machine traffic or things like that, you can actually leverage Vrp on the MikroTiks to do what we've had to do previously in Cisco at a cost of about $100,000. We can do now in MikroTik for a few $1,000s, and that's very attractive to a lot of data center operators. So let's take a look at the conventional data center. This is a design from Cisco. Whenever we sit down to build a Cisco data center, this is what it's going to look like. So anytime you build a data center today with that stuff, you've got kind of a pair of Nexus 7010s, big multiple slot chassis that they actually forward traffic into the terabits. You're going to have a pair of Nexus 5Ks, which is their distribution, and they do 160 gig forwarded traffic between them, and then you're going to have a bunch of switches hanging below that for aggregation of servers and storage and like all this different stuff. And then you've got your internet edge here. You've got BGP peerings with autonomous systems, and you can have multiple. Up here you can have your ISPs, 4 ISPs, 2 7609s, which are 9-slot carrier routers that peer out to the internet. And then you've got your firewalls here. They call it firewall on a stack because it's like a .1Q trunk. And that would be kind of like the load balancer firewall we were talking about. And then down here you've got like some LAN and branch access. And this is anybody goes to work in the Cisco world, build a data center, this is kind of what it's going to look like. So we took this and started to break the pieces down into, well, what does the MikroTik version of this look like? Where do we slot these pieces in? And so we looked at a bunch of different areas of the data center to compete with, Cisco, Juniper, HP, things like that. And the goal of this is to get up to 320 gigabits using CCRs. So in our test lab, we sunk about $10,000 in development in our test lab in Denver to build out our test network, which is a 40 gig core. And that's what we started with. And we're probably going to have some blog posts and maybe some videos as we scale this out, because we have a lot of customers interested in this. So as we scale the 40 gig core out to 320, and it really could go beyond 320, but we stopped at 320 because a lot of routing implementations for equal-cost multipath stop at 16, which is one of the technologies we use to scale the traffic out. So you can actually have MikroTik actually can go up to 128 routed paths. So if you go with those numbers and you have space for 128 CCRs, then you can actually get into the terabit capacity with MikroTik. So 16 CCRs times 20 gig LACP channels, which is your two 10 gig ports and your 1036, gets you to 320 gig. And the design we tested and validated used two CCRs, the 1036, 8G, 2S Plus, and we used two Dell 8024F switches, which are very, very inexpensive switches you can get on the market for $1,500 if you want to go on eBay and get them on the gray market. They've got a newer generation of it that has full support from Dell, and I think they're a few thousand a piece, which is a far cry from the tens of thousands or hundreds of thousands you're going to pay for some of the 10 gig switches in the Cisco world or Juniper. So here's the big question. You get in a multi-million-dollar data center, where does MikroTik fit and why? Why would I go do this? Why am I going to go slot these in? And this is the business case. And this is one of the things we really wanted to stress, because we stress to our customers, a lot of times, we get all excited about the technology and we talk about this is cool, but like, why are we doing this? And the big reason we're doing this is, you look at the business case in CapEx, capital expenditure for a big company, and for really any company, and you've got a much lower CapEx if you're going to go build out a MikroTik data center. You've got lower hardware replacement when a node fails. If you're going to build out a redundant stack of 16 CCRs, you keep a couple CCRs on the shelf, and you lose one, you haven't taken much of a hit in forwarding, and you can go from a $2 to $5 million CapEx down to about $50 to $100,000 CapEx for roughly the same forwarding. Now, that's not to say that the Cisco Nexus and the MikroTik are pound for pound, feature for feature, the same thing. They're not. They're designed to do different things. But a lot of data centers we've found don't really need all the bells and whistles that come with the higher end lines. And so, oddly enough, we'll look at a lot of data centers that have millions of dollars in equipment, and within their switches, they'll forward a whole lot of traffic with the storage replication. But when it comes to inter-VLAN routing, a lot of these data centers that have multi-million-dollar switches, sometimes they don't even go above 10 gig in just routing between VLANs across the board. And so looking at those numbers and looking at the trends and the way traffic gets routed across the data center, we thought, well, there's no reason why we can't take CCRs and slot them into a layer 3 core for a data center. And that gets you down to those kind of numbers, which the mining country guys tend to really, really like that. So, I showed you the Cisco version. This is an overview of the MikroTik version, at least as we were building it in our lab in Denver. And this, by the way, if some of you guys can't see this, I try to make it as big as possible. This presentation is going to be published, and we'll actually have some notes on our website, ArchiTechs.com, which is at the end of it. And you can stop by the booth, and we'll give you guys some Tic Tacs and cards. It's got our website on it as well. And this is what it's going to look like. And the center here is actually built. This portion is actually built in Denver. And the hardest piece of this actually was getting the servers to generate 40 gig of traffic. Getting a server to spit out 40 gig of traffic, we had to get some pretty beefy servers to pump that kind of juice through the CCRs. So you got your Dell stack here. The stack is important. We'll get into in the redundancy because you want your spanning tree domain to be as simple as possible in a data center. You don't really want to get into having to block a whole bunch of stuff. So stacking the switches makes it appear as one switch to the CCRs, and you can build your 20 gig channels for your 40 gig aggregate of forwarding there. And then on down here, you've got your application server and your database server that are going to be sitting in different VLANs, and they're going to be routing up this stack here as we get into later in the presentation. Over here, this is pretty common deployment these days in the MikroTik world. You've got your CCRs doing BGP peering. In this case, we got a lag, 2 gig lag going to a CCR, going to tier 1's level 3 and Cogent, and then you've got your second BGP CCR peering to Verizon and Comcast and advertising this particular AS out. So it gives you multiple paths. One of the reasons we designed with LACP, and we'll talk about that too, is we put LACP in just about every design we have. There's a really good reason for it. Is in the world of HA and the world of trying to keep these things online and 5 nines of uptime, you don't ever want to take a routing table change if you don't have to. And since LACP works at layer 2, if you lose a link, your routing table never changes typically, and you can keep on chugging along and not losing packets, and it just contributes to your stability. And then over here, this is kind of what we were talking about with firewalls. That's out of scope for this presentation. We'll get into it later, probably in another presentation, another MUM, or on our blog. But this kind of gives you an idea of how you would scale out if you needed a 40 gig firewall to move massive amounts of data through. This is kind of how you would scale that out with your CCRs. And because this is load balanced, you actually don't need dual 10 gig links on this. You can actually just have single 10 gig links because the load balancer is constantly evaluating each CCR to see how loaded out it is, if it's alive, if it's online. If one of them goes down, the load balancer just takes it out of service and uses the other CCRs to balance the traffic. So let's talk about high availability for a minute. So 5 nines of uptime. Everybody heard of 5 nines of uptime, right? Everybody talks about it, all the data centers talk about it. Getting to 5 nines is not easy. I don't know that I've actually ever worked in an environment where we actually hit 5 nines. We came really close, but you can only have 5 minutes of unplanned downtime per year to hit 5 nines. 5 minutes of outage at 365 days of operation. It's a pretty hard target to hit. And maintenance windows aren't included. If you plan a maintenance window and you say, I'm going to do this on the network at this time, they don't include it in that number, or you probably never get to 5 nines. But in the HA design elements that we would kind of point out for this, we use stackable switches, as we talked about, because we want to use that multi-chassis link aggregation to provide survivability in case you lose one of the switches. So the nice thing about this design is, if you lose any single hardware component, you haven't lost anything. You probably haven't even dropped a packet at this point. And then going to the load balancers, using the load balancers for the different applications allows you to use the CCRs as a single firewall without breaking state. So, that's really the biggest problem is, the packet comes in one firewall, goes out one firewall, and comes in the other, and there's no way to exchange that state relationship between the NAT table and connection tracking. It's going to drop. And that's what the load balancer solves. Bi-directional forwarding detection is great. You can use it on OSPF and along with BGP, and really get your convergence down quickly. So in routing protocols, if you use BFD, I think it's 200 milliseconds is one of the default settings. So it sends a bunch of UDP packets like these heartbeats, and you can actually do this outside of your network as well. Most internet peering providers support BFD. And it actually tells you not only is your path up, but it's forwarding traffic too. So you can converge very quickly if you turn BFD on. And then having multiple internet BGP peers. That's something that's really important to make sure you have at least 2. We found that the more you scale out, the more you have, the more stable your network's going to be, the less affected you're going to have. Anybody hear about, when the internet went down, we had 512,000 routes a few weeks ago. Everybody remember that? The more carriers you had, at least the data centers that we dealt with that had more diverse carriers weren't as affected by that massive internet outage because your chance for failure is less. So getting to 320 gig, we're going to talk about equal cost multipath. Equal cost multipath in the CCR, according to MikroTik, I haven't tested this, but I checked with MikroTik, and RouterOS is capable of 128 gateways. You can take a single route and point it up to 128 gateways equally. And here below, this just shows a static route with 16 gateways, so that to get to 100.64.240.0/24, I've got those 16 gateways I can hit to forward that traffic to. And those would be like your 16 CCRs or your 16 points on the network to go to. And the routes can be installed either by OSPF or static. BGP by itself doesn't do ECMP, but if you run static routes underneath it, or what we prefer is to run OSPF and advertise loopbacks within OSPF, you can pure BGP on the loopbacks, and we'll get into that, and that can utilize ECMP as well. So using the multiple gateways allows the traffic egressing the router to balance the multiple paths, but what about the egress? How do you get, you think about if you're on a device, and I've got these 16 routers out there, and all I have is a default gateway. How do I get my traffic to all 16 of those routers? And the answer is something that Microsoft has actually been playing with in their massively scaled data centers, and it's routing on the server. So Microsoft and Linux and a lot of data centers are really big about turning routing on the server now. So Server 2012 supports BGP with VRFs and a whole host of routing implementations. And Linux supports BGP, so you can actually bring the routing protocol all the way down to the server, and then the server knows it has 16 paths to forward, and that's how you get the 320 gig through the MikroTiks. So this is a little diagram that kind of shows what we're talking about here. So with equal cost multipath, I've got my application server over here, and he's churning out packets, and he's got 16 paths to go through. And a little word on that, when you're scaling to these kind of numbers and you're using multiple channels, and you've got the LACP channels, something called hashing comes into play. Some of you are familiar with hashing if you play with LACP and you play with these things. And basically what that means is, if I've got a single IP flow to a single destination, that's not going to be 320 gig. It's when I have multiple IPs with multiple sources and multiple destinations, there's a hashing algorithm that the routers and the switches look at and say, okay, you're going here, I'm going to put you on this link, but you're going here, I'm going to put you on this link. And so you have to be aware that to get to that point, you have to have your traffic balanced coming from multiple source IPs to hash out and get those numbers. So using BGP and OSPF for dynamic ECMP, and this is really one of the best ways to do it, the role of OSPF is really to converge quickly. Your transit subnets, your /30s or your /29s or whatever it is you have for transit to connect routers together, those get advertised in OSPF, and then you build loopbacks on bridges to advertise your loopbacks, and then those loopbacks are what you peer BGP with, because that way, if you lose a path, OSPF converges and your BGP peering will stay up. And because BGP does not have ECMP in the MikroTik codes currently, I think I've heard that it's maybe coming in version 7, but it natively doesn't have it. You have to run OSPF underneath it to get the equal cost multipath installed in the routing table. And the role of BGP is to advertise your data center subnets. So servers, databases, web apps, e-commerce, whatever, it's going to advertise all those subnets to your 16 router CCR core. And it's going to take those in and be able to deal with that as that traffic comes through and balance it out back across in the 16 routers. The other nice thing about BGP is it can be used for traffic management. BGP's got a whole bunch of, we call them nerd knobs, because we were really excited about tuning BGP to flow traffic around. And you can use that to manage your traffic pretty well. So this is kind of what BGP looks like if you're going to do it on the server. You've got an application server here. We did Linux, so is anybody familiar with Quagga? Have you guys ever played with Quagga on Linux? You know, see a few heads nodding. Quagga is a good one. There's a few other implementations that you can use. We found Quagga to be pretty good, and you just build, just like Cisco. If you've ever used the Cisco command line, it's pretty similar. And what you can do is put your BGP in this AS right here, and use OSPF to advertise the loopback, and then BGP AS 100 will form an eBGP relationship and peer into, sorry, that's right, it'll peer into AS 65,000, and then same OSPF area, database servers, get their loopback advertised, BGP peers between the two loopbacks, and AS200 gets advertised. And then once you get into the routing table, you'll see all 16 paths for those routers in those servers and vice versa. So you can balance across those links to get back and flow that 320 gig of traffic through. One of the other ways you can do it, and it's not quite as effective and it's not going to get you the same numbers, but if you don't have the ability or really don't desire to run routing on your servers, one of the other things you can do is actually run what we call offset Vrp Gateways. So we'll say, for the sake of argument, to make it simple, we have two CCRs we built in our test network, and each CCR is the Vrp master for one or more VLANs. So in this case, CCR1 is the master for VLAN 100 and the backup for VLAN 200. CCR2 is the backup for VLAN 100 and the master for VLAN 200. So the point is, everything for VLAN 100 goes to CCR1, everything for VLAN 200 goes to CCR2, and in that way, you can actually balance your traffic out across the two CCRs without having to put routing protocols on. So that's very helpful, and you can certainly scale out that way. If you have 16 VLANs, you can do 8 on one and 8 on another. If you have 16 CCRs, 32 VLANs, you could do 2 master per CCR and balance your traffic out that way, and it's fairly easy to do that. So let's talk about LACP a little bit. LACP is an open channel, open standard for aggregating layer 2 links. It's 802.3AD. Sometimes referred to as channeling, bonding, teaming, link aggregation. It's called a bunch of different things. And you can trunk it with multiple VLANs and multiple layer 3 gateways. It can be used with Vrp. Here on our CCR, we built a 20 gig LACP channel into the Dell switches. And you can see in the channel here, the 802.3AD is what lets you it's LACP. This is just to give you an idea of what it looks like on the server side. If you go to Microsoft, they have the 802.3AD teaming there, and if you go to Microsoft NIC, that's what it'll look like. You can lag your two 10 gigs together on a server, which is quite common. Typically, they're lagged across both the switch stacks, so that if you lose a switch again, you don't lose your server or your router. This is what it looks like on Linux. You got a 20 gig channel here, and you can see the 802.3AD in there as well, and it's trunking multiple VLANs through. And so the final result, and what we're actually going to, we didn't get a chance to take any videos of the CCRs in action and things like that, but probably in our blog on the website, we're going to publish some real-time stuff so you can actually see the stuff pumping through the CCR. But using iPerf, which, have you guys ever used Bandwidth Manager or the Bandwidth Tester and then the MikroTiks and put the traffic through? It's actually based on a Linux package called iPerf, something that they had reused to do the bandwidth testing. Unfortunately, the package in the MikroTik tester is not capable of putting 40 gig of traffic through, so we had to use CentOS and Linux on these. I think we used two 8-core servers or CPUs and server to pump this out. I didn't build those; they had the server guys build those out to do that, and they did a good job because we hit 40 gig. So let's talk about multiple data centers. We looked at pushing a bunch of traffic within one data center. What if we want to network together multiple data centers? And I use 2 here for simplicity. This could be 6, it could be 10, it could be 8, it could be across the world. And the 2 big things that MikroTik does a really good job of is solving the layer 2 connectivity piece between data centers and then the layer 3 MPLS piece. The layer 2 piece is important because in a lot of data centers, if you guys have ever worked with virtual machines or played around with virtual machines, if you have a data center go dark, like what happened on the internet recently and 3 weeks ago, if that data center goes dark and you've got all these VMs that need to fail, a lot of VM implementations require layer 2 adjacency for that VM and that IP to move over to the next data center and spin up. So getting layer 2 transit, if you get layer 2 transit from the carriers, it's pretty expensive. We just had to do cross-country layer 2 transit for 2 data centers, and I want to say it was like $16,000 a month for the gig layer, 2 gigs of layer 2 transit. So it tends to be fairly expensive. One of the great things that we're going to get into is EOIP. You can buy 2 cheap internet links. Gig internet links are way cheaper than private transit. You can get 2 1-gig internet links on either side fairly inexpensively, throw EOIP over them, and start to use EOIP to move your traffic. And you can even use frame fragmenting if you need to get your MTU up, EOIP frame fragments, so you're not stuck taking a lower MTU. Now you take a little bit of CPU hit, and in our testing it adds a few seconds of latency when you do the frame fragmenting, but if you need to pass a full 1500 byte frame, or if you even wanted to do a jumbo, you could. And that's what we use EOIP for. And then you've got your layer 2 BGP and MPLS cloud that you can build between the 2 data centers, which also, if you're going to use public transit encrypted over IPsec, like a tunnel, then you would build that over probably EOIP as well, past the MPLS stuff there. So using MPLS in the data center, CCRs can be used as MPLS edge routers to connect to 2 data centers. You can use them to segregate traffic within and between the data centers. You can use layer 2 VPNs to provide layer 2 connectivity and isolation. And you can use VRFs to segregate customer routing tables within the data center so that more than one customer can use the same subnet without overlap. And this is, I tried to find a little clearer graphic of this. This one's a little fuzzy. But you've got MPLS customer isolation at layer 3. So if these are our 2 data centers, and these are our MikroTiks doing MPLS, I can actually virtually segregate customer A, B, and C across the MPLS core, and they will never see each other. This is popular for banks. We do a lot of work overseas. Actually, we're working on deployment of this in Nigeria. There's about 300 banks that want segregation of their traffic in Nigeria on the carrier networks in Nigeria, and we're actually working with them to try to get that, bring that up and segregate that traffic out so that it's safe. And here you've got UIP. You can build your UIP tunnels across your 2 edge CCRs here, and once you build that out, you can drop VLANs below it. And then you're tagging VLANs and extending the same VLAN that's in one data center, in this case, Denver, Colorado, and this data center here in New York. You've got these 2 VLANs extended all the way across, and you can do a lot of things with that. You can also break a lot of things with that, too. So, Vlan Rewrites. This is one of the things that we've seen really useful for the MikroTik, and we thought was really cool, because because we've had to do it in Cisco Metro Ethernet switches. The Cisco Metro Ethernet switches are really, really expensive. They do a great job, but they're very, very expensive. And so if you've got VLAN 100 in data center 1 and it's on 10.1.1.0.24, and then you suddenly have to connect to data center 2, you've got a new connection, and it uses 192.168.222.0/24 on the same VLAN, you tag those together and you're going to have a big problem because you have all this stuff colliding that wasn't meant to be there. So when extending the VLAN between the data centers, you can actually rewrite the VLAN to a different number, but it's the same LAN broadcast segment. So CCRs can do this via bridging. Some MikroTik routers have switch chips, and they've actually got it's a Vlan ingress rewrite that you can use, and that works out really well for doing this. And this is just a quick example. If I've got my data center over here and Vlan 100 is tagged here, and I build my EOIP and transit it through the EOIP here, I can actually rewrite it via bridging into Vlan 3100, and then the tag is unique on either end, but it's still the same traffic, and it's basically the same subnet. And it's pretty straightforward to create. You create some VLAN interfaces on the interfaces that you want. This one's VLAN ID 100, this one's 3100. You build your bridge, VLAN 100 to 3100, and then you put your two VLAN ports in the bridge, and it's pretty much as simple as that, and it works really, really well. It's actually a lot easier than Cisco. It takes about 60 lines of config to do that in a Cisco Metro Ethernet switch. And then the last part of it is dual Vrp gateways. And this is a really, really interesting problem that you have when you're extending layer 2 between two data centers. And we also had to use some really expensive equipment to solve that problem until we started playing around with MikroTik. And the problem is when you extend a VLAN between the data centers, if there's not a local gateway for a host in that subnet, if you're a server and you're on 100.64.100.101, and that VLAN's been tagged all the way across the other data center, and you've got to go somewhere off your LAN segment to go route out. Say it's the internet, it could be another server. If there's no gateway for that LAN, that data center, you're going all the way from Denver to New York to hit your gateway and route and come all the way back. And they call that tromboning because it makes this big U. And so if your latency is 50 milliseconds normally between the data centers, when you do that tromboning through the data centers, it doubles and goes to 100 milliseconds. So it's very, very bad. Cisco actually figured out how to do this quite nicely. You can actually do dual Vrp gateways, and that IP is actually wrong. That should be .1, not .2. But you have the exact same gateway in both data centers. So you have 100.64.100.1 in data center 1, and 100.64.100, and imagine that's a 1, not a 2, in the second data center. So you get the exact same gateway, but it lives in each data center and traffic routes locally and not across the data centers to do this. And because Vrp uses MAC addresses that are derived from the Vrp group number, hosts are always going to find the gateway in their own data center before going to the other data center, because if it's the same MAC address and you're going through your MAC table, you're always going to find that MAC within your data center before you're going to reach out and go hop to the other one. So it works really well. They go to their local gateways and they go route out without hopping across to the other data center. And this is kind of what it looks like. The only thing you do have to do, you got to be really careful about this, because I took an entire data center down because I forgot to put this rule on, and it's very, very bad. The Vrp protocol 112, if you don't filter that between two data centers, then you potentially can be master for the other data center. So what can happen is, if you don't filter that out, it's Vrp uses a multicast stream to talk and say who's the master for this gateway, who's the backup. When you're doing this, you filter that out, because if you become master for the other data center, suddenly all that traffic in that data center in New York flows over to Denver. Bad things happen. So basically all you have to do is add a Vrp gateway for 100.64.1 in both of the data centers, and with that filtering on, as soon as I added this filter, both of my Vrp gateways went to master because they no longer can see each other across the layer 2 link. And in that way, you can forward your traffic out both data centers for that extended subnet. And this is really, really popular for the guys that play with VMs. Any of you guys play with VMs, you're doing VM hosting, things like that, this is something you want to look into, because you can start building redundancy between your data centers. You can have a colo somewhere here, have a colo somewhere else, and if all that colo does is drop you out internet access, you put your CCR in, you do your EOIP tunnel, you build your dual default gateways out, and suddenly you've got the ability to move your VMs and fail between data centers like the big boys. So it gives you a lot of leverage and a lot of things that you can do with that. And this is an example of what the dual Vrp gateways look like. You've got traffic here, and it's going to go out locally, and you've got traffic here, and it's going to go out locally. And then when you split a subnet like that, the same subnet, what you do have to do, if you've got private routing that brings you back, what you may have to end up doing is doing like /32 routing to bring first. So if you've got a .101 server here and a .102 server here, you may have to advertise a /32 route so that you return the traffic to the right data center for the right server. And to reiterate, since we've reached the end, it says 4 to give away. That was yesterday. We actually have only 2 to give away now. So all you have to do to get one of the team of helicopters is like us on Facebook at IPArchitechs.com and send us a message so that we have your contact information, name, phone number, and email, so we can contact you when you want. And go ahead and open up for questions. We publish this on our website. I think MikroTik also publishes this as well. That's my email address and my office line. If you want to contact me, feel free to. I'll go ahead and open up the floor for questions. Anybody wants to talk about MikroTik in the data center? Yes, sir.
I was on OSPF. I noticed that you changed the hello timer and the dead timer down to 3 and 1 second.
That's right.
Is that easy? Is that a good figures for like wireless, where you're further apart than you would be in a data center?
We, if you're doing it over wireless links, we found you typically, that's a case-by-case basis. We've had to bump those up when we work with the WISPs and WISP backhauls because that's tuned for fiber. So if you've got a really, really clean, like an air fiber link, you can probably get away with doing that low of a timer and you don't have a lot of loss. If you've got a link that you may have some issues with and you don't want to bounce OSPF all the time, you might want to up that to like maybe, 3 hello and 9 or something like that, and just, that's kind of a case-by-case basis. But in working with a lot of carrier networks on the wireline side, we found 1 and 3 to be a really, really good OSPF set of timers, unless you're going to go with BFD. And if you go with BFD, then you don't really need the timers for OSPF because BFD is taken care of it. Any other questions? Yes, sir.
I may have missed something because I was reading an email at the same time, but when I saw you do the EOIP tunnel between the 2 data centers, any recommendations as far as security there?
Yeah, what we tend to do is, it works really, really well, is you actually do an IPsec for the EOIP. So if you do an IPsec for the GRE tunnel, the EOIP and just the GRE protocol, so your IPsec essays would be like, from this IP for GRE to this public IP for GRE, you're going to encrypt for IPsec. And that way, if you point the EOIP targets to each other, then only that EOIP traffic gets encrypted, and then you can not only tag VLANs across that, and everything gets encrypted because the underlying public transport is encrypted. You also can tag your VLANs and pretty much do whatever you want. And that's the way we tend to use it a lot. We've been experimenting with SSTP now as well, and that's another encryption transport that you could look at using. A lot of it just depends on your performance needs. One of the things you'll find with Router OS that I'm sure a lot of you guys already know is, with respect to encrypted throughput, different applications perform differently on speed with IPsec versus SSTP. And if you really wanted to go insecure and you weren't terribly concerned about security, you might even use PPTP if you really just didn't need that much security. I probably wouldn't recommend it, but you may have a speed application that you're not concerned about security that you need to get the speed up on. So that's the way we'll look at doing that. All right, yes, sir.
Have you done any testing on non-MikroTik with Router OS like i7s or other hardware?
I haven't done any testing on like non-MikroTik hardware as far as the speed and throughput testing. We have talked about doing some of the x86 with the 10 gig cards. That may go into one of our lab racks in the data center in Denver to test out and see what you can do with some of those. So far, because the demand is so high for CCRs, that's mostly what we've been working with. But it's something we've talked about and we're looking at. Any other questions? All right. Okay. Thank you very much.